Hello everyone and welcome back to the video series wherein I will tell you how is that you use Gromacs on Windows, the Grovin program for initiating, setting up and running the MD simulation of a protein ligand complex. So I would assume that you have already downloaded the Gromacs and install it on your computer. But for the sake of simplicity, I would again give you a kind of hint that you should make sure to install the Gromacs in the program files folder. By default, it will be installed in program files x86 folder. I will just show you where is that you are supposed to install it. In your C drive, by default, it will be it will be installed in this program files x86 folder, but you have to change that folder to program files folder wherein you will install it in a folder called as Gromacs, and in bin there should be this executable of your Gromacs. So this is important, otherwise your software will not work properly. Now, once you have installed it properly, there will be an shortcut like this. Double clicking this shortcut will open the Gromacs uh, command line prompt. Now, let us begin our work in Gromacs. So, before we begin, I assume that you have already downloaded the material, or what I have provided is some tutorial material. In this file section there is this folder called as protein ligand tutorial, and you are supposed to download all the files that are required for successful implication or running of this Grovin into your Windows operating system. So I have already downloaded it, and maybe I will show you what are the files that are there. So this tutorial contains this one of this, what we can say, a PDF file which you can open in any PDF reader, Adobe Reader, and whatever detailed preparatory steps are there, I have already mentioned and shown it in quite really very detail as to how you are supposed to create input files and how you are supposed to parameterize the ligand files, so on and so forth. So now, assuming that you have the parameters for your ligand, I have used Swissparam for obtaining the parameters for my ligand, and I have separated the receptor and the ligand molecules in PDB format, and this is where our tutorial will begin. So, if you have any problem while generating or separating the protein and ligand, or while parameterizing the compounds, you might refer this tutorial for the sake of simplicity. So, this is the zip file that is usually obtained as a result from Swissparam when you attempt to parameterize your molecule. So now what I will do is that I will extract this folder into some folder wherein all the files that are given as a results are already there. Of this, we would need this lig.itp file that is essentially required for running Gromacs. The other remaining files, well, so for example, this PDB, PSF pair and RTF file, this is a topology file, parameter file. Well, these four files are meant to be generated for NAMD if you are using, but this ITP file is meant to be used for Gromacs. So from the Swissparam output, this ITP file is what we will be needing later on. So let me simply copy this and paste it in my working directory, right? So once you have copied and pasted this ITP file, the next thing that you are supposed to do is to change the working directory. Well, now my friends, the test folder that we are using for this tutorial purpose, it is placed on desktop. So what we will do is that we will copy the location of this folder, and currently when you start Gromacs, it is there in program files in the folder called Gromacs, right? So what we will do, we will simply change the directory by using this cd dash dash command, and simply I will paste the location where my input files are located. Maybe I will give the dir command to just confirm that we are in the right folder. All the files that are listed over here, make sure that they are also present in your working directory. So after making sure, now let us begin the simulation process. Well, well, now since my working directory is in the C drive, therefore there was no need to change the drive, right? But if your working directory is somewhere else, like in D drive or E drive, then you might want to first change the working drive and then give the command to your folder location, or what we call it as the working directory location. Okay, so one more thing, I have provided the list of commands that are used in this tutorial in a separate text file named as gromacs.txt or gromacscommand.txt. You can open it in any uh, in any of the uh, text editor, right? And you will see that these commands can be used. Okay, so I would advise you to copy commands from this gromacs command.txt file rather than from the PDF that I have provided. Okay, or you can simply type it without making any spelling mistakes in this command prompt, so that there would be no any inconvenience while you use this computer program. All you need to do, in short, is that you need to simply copy and paste the commands that are provided over here. That will completely solve the issue of giving the wrong command, right? So for example, if you want to use this pdb to gmx command, simply you are supposed to copy this and simply copy it and simply paste it and hit your enter button. That will take care of everything, right? So the first step is to convert your pdb file into gromacs interpretable uh, gmx file as such. Okay, so for that we would be using this gmx command, gmx pdb to gmx, and once you copy and pasted this material, just hit enter. Now once you hit enter, a menu appears that will prompt you to select the force field. We will be using charm M force field. In our case, it is located at number 8 in the menu. Therefore, we will type 8 over here and hit enter again. Now another menu has appeared that is asking for the selection of water model that you are supposed to use. So we will be using the recommended TIP3 point water model, which is there on the first option. Therefore, we will hit 1 over here and press enter. This water model is offered on the first position, and hence we typed 1 and we pressed enter, and as you can see, something happened, and now there are 3 files that are newly created in your working directory. If I simply sort by date modified, so these are the 3 files that you can observe that are newly created. Now let me tell you what these 3 files are. So the very first file is topol.top. This is the topology file that we will be needing it a lot of time and we need to edit it later on. The next file that is generated is this conf.grow. This is protein coordinate file in grow format. And the third file is posre.itp file, which contains data on position restraint. This file is sometimes also called as position restraint file. So if the command runs successfully, as it has happened now, Gromacs usually prints a quote that starts like Gromacs reminds you, and then there would be certain quote that will be there. So the objective of this command pdb to gmx was to obtain the protein coordinates in Gromacs readable grow format. Now we have dealt with the receptor. Now let us now uh, deal with the ligand molecule, because our system also contains the ligand. So we need to prepare our ligand molecule. So what we have now is the protein, this file in its grow format. Now we need our ligand as well in the grow format. Currently our ligand is there in the pdb format. To do so, we need to simply run the command as I will show you over here. We would be using Gromacs edit conf command. So what we will do, I will type this command just to show you how things are there. Gromacs edit conf, then we will be providing the name of the input file by giving this dash f. The name of our input file is lig.pdb. Therefore, we will mention it over here as lig.pdb, and we will simply mention the output name by giving this dash o command, and let us call it as lig.grow. We need to use the proper name. Okay, my friends. So once you have written the command very carefully, and when you hit the enter again, the as you can see, the Gromacs has successfully launched the command, because you can see that there is a quote over here which indicates that the command has been successfully executed. So before you execute this command, make sure that this lig.pdb file is already there in your working directory. Okay, moreover, this lig.pdb should be the same file that you have obtained from the SwissParam server. Okay, so don't get confused. Whatever pdb file that you obtain as a result from SwissParam server, that is supposed to be used in the previously configured Gromacs edit conf command. So again, as you can see, after execution of this Gromacs command, it has generated a single grow file called as lig.grow. You can simply check out its property, and in property you would see that the name or extension of this file is lig.grow. When you will be running Gromacs on your PC, the icon might look different, but just make sure that whatever the type of the file is, that is located in this column of your Windows system. So you can check it out if you have all the files already which are necessary for your simulation. So now at this stage, we have topologies of both ligand as well as your protein. Ligand topology is there in form of this lig.grow, and protein is there in form of this conf.grow. But now you can see that these are two separate files, and during performing the simulation we would need them as a complex, and hence my friend we need to merge them into a single file, and we can do that successfully using any text editor. So now let me open this file in any text editor. As you can see over here, this is the lig.grow file that we have recently generated, and this is the conf.grow file that we have generated. Okay, so now what I will do, I will begin copying all the lines that begins with the keyword lig. Like from here I will copy everything. I will simply copy this, and I will go to this conf.grow, and when I reach this conf.grow, what I need to do is to scroll down to the end of the conf.grow file. Now we need to locate the last line of the protein. It should be like this: PHE, then OT2. This is the last line of your protein, right? So once you reach the last line, just hit an enter and simply paste what you have copied from the lig.grow file over here. Okay, so this might change the column positions of the coordinate value. As you can see over here, the column position of xy and z coordinates are now changed, that there are a few differences, right? So what we are supposed to do now, we are supposed to provide spaces at appropriate places to align all the coordinates that are there between the protein as well as ligand. So what I will do is that I will simply remove some of the extra columns that have been added over here. Okay, and maybe I will click here and I will paste the, it didn't work. I will again select two blank spaces. I will copy it and I will simply paste it. Now you can see all the coordinates are properly aligned. Okay, now I am satisfied that everything is in right place. Okay, so once you are done with this copying and pasting and adjusting the coordinate of the x, y, and z coordinate of each and every atom from your ligand, you are supposed to now scroll up in this conv.grow file, and on the second line you might see a number 5050. This number indicate that there is information of protein on 5050 lines in this file. Similarly, you might note that in the ligand.grow file, the ligand information contain with like 33 lines. That means the ligand information, coordinate information is there in 33 lines. So now what we need to do is that we need to add this 33 to this 5050, and whatever the sum is, we need to replace that number with the sum of the total number of lines that are there in your ligand plus the total number of lines that are there in your protein molecule. So 5050 plus what you have got is 33. If you add them up, it would become 5083. So this 5083 is to be placed here on the second line. Then and then, my friends, the Gromacs software will consider it as an entire complex. Now this number 5083 indicate that the merge topology file has got information of both protein as well as ligand spanning over 5083 lines. Now conf.grow file contains topology data of both protein as well as ligand. So what we will do is that we will save our work, and now we can close the text editor. Next thing that we need to do is to edit the topol.top file that I have already mentioned that we need to do that. Okay, once you open your topol.top file in any text editor, this file actually contains the information of the system, and at this time it don't have any definition of ligand in it. Therefore, we need to add this information so that Gromacs may recognize ligand as well as protein. To do so, you can open the topol.top file as I have shown it over here. So, and you are supposed to locate the section that tells about force field parameters. I am talking about this section. And what you need to do is that you also have to now add the information of your ligand molecule by typing this simple code. You are supposed to provide a semicolon and then include ligand topology and simply include the name of the file that contains the ligand topology. In our case, it is lig.itp, and to include that, the code is like you are supposed to provide this hash and state include statement, and in double quote provide the name of your ligand, that is lig, and its extension ITP. So once you are done with this thing, simply press this save button. Okay, now your topol.top file should look something like this. Okay, so we are not done here. So including these two lines now enables your Gromacs to recognize the ligand along with the protein. Additionally, we also have to update the list of molecule at the bottom of this topol.top file. So again, you need to scroll down to the very end, and scroll down till you reach this file, this particular section that gives you a kind of idea as to how many molecules are there in your topology file. So currently there is only information of protein molecule. We will have to update it with saying that there is also a ligand, and whatever number of ligands are there, they are supposed to be placed over here. So if there are two ligands, then you might write it as 2, or you can simply put the name of ligands over there as whatever is convenient. Okay, so once you have updated this section, updating this section enables Gromacs to understand the system contains one protein and one ligand. If there are multiple ligands in your system, then you need to make appropriate changes over here, and you need to save it. Okay, so we are done with editing this the grow file. We are done with editing this topology file. We now also need to check the ITP file that I was talking about for this ligand. Let us open it in Notepad again. So this ligand's ITP file contains all the force field parameters like stretching, bending, dihedral, etc. For the ligand. Here you just have to make sure that the name of the ligand is right. So for doing so, you need to locate the line that starts with maybe this one, molecule type, and then semicolon name NREXCL. So just make sure that there is lig 3 written over here, right? So sometimes what happens is that if you change the name of the ligand during saving files, this section can sometimes change. So just make sure that there is only lig 3 written over here. It basically connects the parameters to the topology data. Okay, now after make sure that you save everything properly. Now you can close. We don't need other things, and now we are ready to roll with the Gromacs. Okay, right now the next thing that you are supposed to do in Gromacs is that you are supposed to create a solvation box. So we will do the subsequent steps in our next video. So if you like this content, please make sure that you hit the like button, subscribe the channel, and see you guys in our next topic.